An enterprise AI agent synthesizes thousands of pages of complex manuals, proprietary data tables, and internal operational rules in seconds. But behind the seamless text generation, there is a massive computational toll. Every single user query extracts a specific and intense demand from the underlying hardware. To understand a 50-page document, the model has to calculate the mathematical relationship between every single word. It maps out context across dozens of layers, running millions of operations before it can generate the first word of its response. While artificial intelligence itself is abundant, compute speed and latency remain the primary bottlenecks preventing these systems from running at an enterprise scale. This problem exists because large language models are stateless. They possess zero persistent memory or awareness between individual user queries. When you ask a follow-up question about that same 50-page document, the AI must reread and recalculate the entire text from scratch. These temporary mathematical relationships are stored as key value, or KV, pairs. These are the model's fleeting internal map of your prompt, and currently that map is discarded the moment a new query begins. This operational amnesia causes a significant waste of processing power, driving up both response latency and infrastructure costs. Standard software engineering uses caching to bypass redundant processing and speed up data retrieval. In the context of AI, we must distinguish between output caching, simply saving a previous answer, and the more sophisticated prompt caching. Prompt caching stores pre-computed key value pairs of the input prompt. This prevents the model from doing heavy lifting twice. This optimization requires scale. Caching only provides measurable benefits when processing large inputs, typically exceeding 1,024 tokens, the basic units of text a model processes. This shift allows models to skip millions of operations and jump straight to generating new thoughts. To utilize the cache, developers must design the architectural structure of the prompt with precision. This is governed by prefix matching. The cache reads the prompt token by token from the beginning and stops functioning the moment it detects a change. This requires a specific sequence. All static, heavy data, like system instructions or long manuals, must be placed at the very top of the prompt. The dynamic variables, specifically the new user question, must be placed at the very bottom. This allows the system to recognize the massive cache document above while only processing the new request. If the dynamic question is moved to the top, the cache fails immediately. The system is forced to recalculate every word of the heavy data following it. Strict discipline in prompt architecture ensures the system achieves near instantaneous response times. Prompt caching is a critical strategy for FinOps, the financial management of cloud operations. It is necessary for reducing the total cost of ownership of large language models. As shown in this chart of TCO reduction drivers, optimizing prompt architecture systematically drives down baseline inference costs and reduces input token expenditure. This is mission-critical for RAG-native applications, retrieval augmented generation, which constantly inject large repetitive knowledge-base documents into the context window to ground AI responses in facts. Effectively managing latency and token overhead transforms an unpredictable R&D expense into a highly scalable, predictable enterprise asset. These optimization techniques are central to the Anven ecosystem, which is designed explicitly for secure, isolated enterprise deployment. Anven's natively optimized models utilize advanced quantization, specifically int4 weights and int8 activations. Quantization reduces the numerical precision of model weights to save memory, compounding the speed advantages provided by prompt caching. Combining intelligent prompt caching with Anven's lightweight architectures allows organizations to achieve true sovereign AI, with maximum intelligence running entirely within their own firewall. Enterprises can now eliminate redundant compute cycles and reclaim their infrastructure. Visit Treecapital AI to audit your infrastructure and deploy the Anven framework.